Hi, my name is Alonso Jose and this is the second partial exam for the subject Process Automation Laboratory, in which we are going to be talking about Cascade Control. So, what is Cascade Control? Cascade Control is an implementation that can allow any application to be more responsive to disturbances, in which we are going to use multiple control loops that can signal and manipulate different variables. Before we even get started on what a cascade control arrangement is, I would like to talk about the pros and cons of having one instead of a single loop control or another type of control. First of all, since we are going to have two control loops, we're going to be much more sensible to disturbances, which means we're going to have a faster response to these disturbances. This also means that we're going to have a smoother performance. So it's going to be much more steady if we would like to see it that way. On the other side, on the cons, it is much more expensive than a single loop control, since we are going to need much more equipment and instruments. For example, instead of one, we're going to need two controllers. We are going to see that in a minute. Also, the tuning of a cascade control is much more complex. So we can see that a cascade control could be used for different cases in which we need the controller to be much more sensible, or we can choose if we're going to need another type of controller. So here is a block diagram of a cascade control arrangement. So what is really important to understand, and the main difference between a single loop control, is that on a cascade control we're going to have two or more controllers, the first one and the second one. So it is really important for us to understand that one controller's output, it's going to be the set point of the other one. So it is constantly going to give feedback to the second one. Now that we know that we are going to have two different controllers, it is almost obvious that we're going to have two different control loops. Here is the first one, in which we are going to have the first measurement of a signal, okay? And then we're going to have the second loop, in which we are going to have another measurement. They are going to be different. The important thing is that we are going to have one primary variable, which is going to be our set point. That is really important. So we are going to have two controllers, two different control loops with their respective measurements, but we're going to have one desired variable. Now it's time for us to see a real-life application of a cascade control arrangement in the industry. So first of all, let's forget about PIDs and controllers and cascade control. We're going to see how the system works. We're going to analyze our system as engineers. So we have a tank with water that is going to have an inflow and an outflow. The problem is that we need that the outflow needs to be at certain temperature. It needs to be, for example, at 50 degrees Celsius. So what we're going to do is going to run a coil through the tank that it's going to have steam running through it. So we're going to have a constant inflow of heat to the water that is going to heat the water into the desired temperature. This coil is going to have a ball, as seen here, that is going to control the amount of steam running through the coil. But so we as engineers need to have this temperature really constant. If it's a chemical process, it needs to be at a certain temperature. It cannot be higher, it cannot be lower, it needs to be there. So how can we control that the outflow is always constant? With a cascade control arrangement. But then you may ask, hey Alonso, why do we need two controllers instead of just one that can tell us the temperature of the outflow? Why do we need two of them? Well, it is really important to recall what we've seen before. We're going to need two controllers because the output of the first one is going to give the set point to the second one. So, as we can see on this diagram, we're going to have our first variable given to the first controller, which is going to be the temperature of the outflow. But what if the water is it's too hot, or what if it's too cold? If it is too hot, we need the system to go down. So the first controller is going to tell the second one, hey, close the bulb because there is too much heat in the reactor. We need much less heat. The water needs to be colder. So this one is going to tell this one to close the bulb a little bit. If it is too cold, it's going to tell it, hey, open the bulb, we need more heat. If the water is just right, this controller is going to tell this one, it's okay, don't do anything because we're just doing fine. So I really hope you enjoyed this video as I enjoyed making it, and I hope that my teacher touches his heart and he gives me 100 because I really put a lot of effort in it, and thanks for watching.